Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. This is Muhammad Al-Jabu, and in this video I'm going to cover the requirements for Embedded Control System Assignment 2, in particular Step 3. So in this video I'm going to talk about the PID controller that we developed in the ESP32 to control the speed and direction of the motor and see how it reacts when we introduce an error to the PID controller. So let's begin. First of all, we can see the the code on the left side of the screen here. So we begin by declaring some constants to be used in the program, and then next we declare some variables, global variables, to be used in the logic, like time, delta time, previous time, and so on, which can be examined more closely by looking at the code fully. I'm not going to spend a lot of time explaining every single one. Then we have some gain variables. Next, we have some variables for the motor driver, some custom function, encoder, interrupt service routines as explained in assignment 1. And then next we get to the setup function. We set up the pin modes. The encoder interrupt enables, then the PWM channels, and so on. This is not used yet, but this is for future testing, which is for the light detector input. It's not for the purpose of this assignment. Next is we initialize or start up the serial port, and then we print a greeting message and introduce a small delay, and then we move on to the loop function. In the loop function, we begin by noting the system time and calculating the time change from last loop scan or last loop iterations. And then next we calculate the RPM based on the current encoder counts and the count from the previous loop run. And then finally, after going through the calculations, we end up with RPM values. The RPM values then go through a filtering process, or a quick first order discrete filter, which just removes the high frequency component or a fast changing component of the RPM, which gives us a better and more stable performance with the PID controller. Next, this is commented out. This is just an automatic sequence to manipulate the set point. But for the purpose of this demo, we'll just enter the set point from the serial plotter message window. So it just waits for the value to come in, and you takes that float value and uses it as a set point for the right and left motors. And next we come to the PID calculations. So we're doing the two left and right PID calculations together. So we start by calculating the error, the cumulative or integrated or time integral error, and then the rate of the error, which is the derivative for both. And then we finally calculate the PID gain output based on the gain values that we defined at the top of the code. And then we do some error checking or some safety checks. Let's say if the set point is 0, make sure the output is 0 to prevent the very low output from slowly driving the wheels. This is based on experience after running the PID a few times. And then next we limit the output between -100 and +100. Then finally we output to the motor driver, and then we update the previous value registers or variables, and then we print the data to the serial port. So on the right hand of the screen, we have the camera window where we can see our experiment mobile robot for this course. And we also, at the top of the screen, we see the serial plotter window. So what we'll do is we'll enter a set point of 50, then we'll see the value here. See the blue is the set point, the purple is the actual value. Then we'll change it to -50 to see a negative, introduce a negative error, and then see that it jumps down and tries to catch up with the set point, and it hovers around, and we can see our wheel is spinning as shown by the video. We go back to 0, it will stop. So back to the point number 3, this we've successfully combined the programs for the motor driver, encoder, RPM calculator, and the new PID algorithm into one program, and we have successfully shown some reactions from the PID when it encounters error. The error in this case is the sudden change of the set point. That's it for this video. Thank you very much for your time, and assalamu alaikum.